Hello everyone, welcome back to Class 6 series on my channel Mathify with Minakshi. Have you ever noticed that shapes around us also follow patterns just like numbers do? In today's video, we will explore shape sequences and understand how shapes follow a pattern, how the number of sides increases, and how we can predict the next shape in the sequence. So let's start exploring the world of patterns in shapes. Now look carefully at this sequence of shapes. What do you observe? Let's try to understand the pattern together. First, we see a triangle that has three sides. Next, we see a quadrilateral that have four sides. After that, a pentagon with five sides, a hexagon with six sides, a heptagon with seven sides, a octagon with eight sides, a nonagon with nine sides, and decagon with 10 sides. So, what pattern do you notice here? That here the number of sides increases by one each time. So, let me write rule what we use here. So, rule for first sequence we use that add one more side to get the next shape. So after decagon, we need a polygon with 11 sides, and that is here. It's known as hendecagon. It have 11 sides, and it's known as hendecagon. Yes, now let's move to next sequence. Now explore that we have a very interesting pattern here, and that is known as complete graphs. First, look at this figure. We start with K2. The letter K means complete graph. In a complete graph, every point is connected to other point with a line. As you can see here, we have points. So there is one line, then we have this point also. So second line and then third line. So in a complete graph, I'm writing here in a complete graph, every point is connected to every other point with a line. Yes. Now, so in K2 we have 2 points. So here 2 means number of points. K2 we have 2 points. Then in K3 we have 3 points. Then in K4 we have 4 points. And then in K5 we have 5 points. And then in K6 we have 6 points. That means for next year, if you want to draw K7, then what you will do? First you will draw. See here carefully, three sides. So you have drawn triangle, then quadrilateral, then pentagon, hexagon. So next you know that we have to draw this heptagon, that is here. So first you will draw heptagon here. Then what you will do? I will just draw the points for you, so it will be clearly visible to you. So we have this heptagon. Now that's the meaning of 7. But what is K? K is complete graph. That means every point is connected to other points. So let me start from this point. So we'll join all the points except the adjacent ones, because adjacent ones are sides. That is already, we have a line there. Then we'll join this one. Then we'll join this one. We'll not repeat any point. Yes. Then we'll draw this point. So you will try to join all the points with the help of line. Now I will show you. This is just for explanation. I will show you a clear picture. So I will rub this now. Hope so that you know the meaning of complete graph now. So this is the picture of K7. First you will draw heptagon and then you will draw all the lines. Did you observe something here? That here we are just counting the lines. In first we have, in K2 we have one line. Then in K3 we have three lines. Then we have four sides and two diagonals. That means 6. then 10, 5 sides and 5 lines, then 6 sides and 9 lines, that is 15, and then next 7 sides plus how many lines. Now it's very difficult. How will count the number of lines? Is there any formula to count the number of lines? Yes. If you want to count the number of lines, then I'm telling you one formula here, that number of lines is n into n minus 1 by 2. That will give you total number of lines. Sides plus this, it will give you total number of lines. So for this, I'm telling you formula n into n minus 1 by 2. Now just see here carefully. What is n here? N is your that number that is written in front of k. So for k2, you will put n as 2. That means 2 into 1 by 2 and you will get 1. For k3, you will put n as 3. That means 3 into 2 by 2. 2, 2 you can cancel and you will get 3. So for k7, I will put here 7. That means 7 into 7 minus 1 is 6 by 2. You can cut this, it's 7 into 3, that is 21. So you know total lines are 21. That means 7 are sides and 14 are the diagonals. Yes, easy. So just learn this formula so that you can directly count the total number of lines, and even you can verify your answer in case you missed one of the diagonals. So you can just check that once, that you, if you know the formula, you know that at last I have 21 lines including my sides. Now let's write the rule here. So rule is that for kn we have how many lines? For kn we have n into n minus 1 by 2 number of lines. And did you observe something here? What is this pattern? 1, 3, 6, 10, 15. Yes, this pattern is triangular numbers. So the number of lines, this follows triangular numbers sequence. Now there is one confusion maybe, that for triangular numbers the formula is Tn is n into n plus 1 by 2. But here it is n minus 1 by 2. Why is it so? Because if you will see carefully here, this is T1 and in K this one is K2. Similarly, this one is T2, but in complete graph, this is K3. As there we have one more number, that's why here we are writing instead of n, we have to write n minus 1. If you will replace this formula with n minus 1, what you will get? See here, n instead of n, I'm writing n minus 1. Similarly, here instead of n, I will write n minus 1. Then if you'll cut that, you are left with n minus 1 into n by 2. And that's why this is the formula that we'll use in complete graph. Hope so that this concept is clear to you. Let's move to next shape sequence. Third, stack square. Now what is stack square? Here we see small squares are arranged in a pattern. First we have one square. Then we have four small squares. 1, 2, 3, 4. Then we have 9 small squares. As you can see, 3 by 3. That means 9. Then we have 4 by 4. That means 16. Then we have 5 by 5. That means total 25 squares. Do you notice in something interesting here? Yes, these numbers 1, 4, 9, 16, 25 follow the pattern here. Which one? These are square numbers. So each step forms a bigger square made from smaller square. So here, as this one is 2 into 2, 3 into 3, 4 into 4, 5 into 5. So next will be 6 into 6. 1, 2, 3, 4, 5, and the lower one is 6. Similarly, 1, 2, 3, 4. You will draw 5 lines because then the squares are 6. So 6 by 6, that is 36. As we can say, this is 6 square. So let's write the rule here. So rule for stack square is that number of small squares in each row and column of next shape is one more than that of previous one. And one more thing, you can also write that here we are following two rules. First, this number of small square in each row and column of next shape is one more than that of previous shape. And second, that at last, total number of small squares is always a square number. I'm talking about in each shape. In total number of small square, in each shape is a square number. Now, look at the triangle pattern. Here, small triangles are stacked together to form the bigger triangle. First, we have one triangle. Then we have 1 plus 3 triangles. In first row, we have one triangle. In next row, we have 3 triangles. That means total we have 1 plus 3. That means 4 triangles. Then in next step, we have one triangle, then second row 3 triangles, and then third row 5 triangles. That means 1 plus 3 plus 5, you can say it's 9. Each time we add a new row of triangles. Similarly here, one triangle, three triangles, five triangles, seven triangles. And when you will add, that means 9 plus 7, it will give you 16. In next step, one triangle, next row, three triangles, third row, five triangles, fourth row, seven triangles, and fifth row, nine triangles. And total 16 plus 9, 25. So you can see a pattern here that for total number of triangles, we get 1, 4, 9, 16, 25, and so on. And these are square numbers. So here you can see that next will be 36. That means how many lines we want. You have to add here 1, 2, 3, 4, 5. So here you will add 6. 1, 2, 3, 4, 5, and last 6. Okay, so you have to draw triangles. In first step, we have 1, then we have 3, then we have 5. You will draw like design like this, one triangle, then 2, then 3. Then you will get number of triangles as odd numbers. And here, yes. So here, one triangle, second row, three triangles, then five triangles, then seven triangles, then nine triangles, and then 11 triangles. And if you will add, what you will get 1 plus 3 plus 5 plus 7 plus 9 plus 11, you will get 36. The next square numbers. So what is the rule here? That number of small triangles in each row is an odd number. As you can see in first row 1, then 3, then 5, then 7, and so on. So that means next shape has one more row of small triangles, one more row of small triangles than that of previous one. And last thing, that total number of small triangles is a square number. Total number of triangles here is a square number. So these three things you should know for stacked triangles. Now let's move to last shape sequence, that is cone snowflake. So here what you have to do, so we have a rule for that you have to convert every line segment. We have to convert that to speed bump. That means we have to convert this line to this line. One line segment becomes four line segment. So this we have to convert. Wherever we see a single line segment, we have to make this design. I will tell you, like in first figure we have a normal triangle. For second step, again you will draw this triangle and then you will erase the lines. Once it's done, then what you will do to get the second shape, you will just draw this. We have the second shape. Now what we'll do, for third step, again you will draw the second shape again and remove from middle. You have to rub the lines from middle. Every line segment you have to rub. Once it's done, again what you will do, you will draw the triangles. So let's draw that. And once it's done, you will see that you have the third step with you. See, yes, they are same. Similarly, you will draw this figure again and then you will remove the lines from between and draw the design. But here, if you will see these two figures carefully, that means fourth step and fifth step, they will look same. So what's the point to draw the next one? It's very difficult to draw the next one because it will look same, and it will take you one day if you will draw this properly. So what we can do here, we can write that we cannot draw further shapes of this sequence. We cannot draw further shapes of this sequence conveniently because it will take your time if you will draw this properly. So in exam also, don't worry, this question in case it will come, it will just come till 3 or maximum till 4 shapes, mostly till 3 shapes. So it's very complicated to draw, so that's why we'll not draw further. Okay.
So that means we can say that in first step we have three line segments. Then as every line segment is converted to speed bump, that means into four. So you can say next we have 12 line segments. I will show you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Similarly, for next, if you will count, again every line segment is converted to speed bump. That means one line segment converted to four line segments. That is 12 into 4, 48. Similarly, next you can say 48 into 4. That is 192, and in next again into 4, that means 768, and so on. Next also you will into 4, but that's difficult to draw, so I'm not writing that. But you should know this rule of post snowflake, that here every line segment, that's one line segment, converts to four line segments, because in speed bump we have four line segments: 1, 2, 3, and 4. Now let's move to figure it out. That's on page number 11 of your book. First question.
Can you recognize the pattern in each of the sequences in table 3? That we have already recognized, so we are saying that it's already done. Now, let's see question number 2. Try and redraw each sequence in table 3 in your notebook. Can you draw the next shape in each sequence? Yes, we can draw, except the last one, coast snowflake, because that is very complicated and it will take your time. After each sequence, describe in your own words what is the rule or pattern forming the shapes in the sequence, and that I've already explained to you. So this question is already done. So both the questions are based on that table that we have just discussed.
Now let's move to last figure it out of this chapter. Again, that's on page number 11. Question number 1. Count the number of sides in each shape in the sequence of regular polygons. So first you have to count the number of sides. Which number sequence do you get? Then you have to see which sequence do you get. What about the number of corners? Then you have to find number of corners. You can say number of vertices. Each shape in the sequence of regular polygon. Do you get the same sequence? Can you explain why this happens? So you know that we did here this first triangle, quadrilateral, pentagon. So in this we have to tell number of sides and number of corners. Okay, so regular polygon I have written for you, and now we have to fill number of sides and corners. We know that in triangle we have three sides and three corners. In square we have four sides and four corners, and pentagon we have five sides, five corners. In hexagon six sides, six corners. Heptagon seven sides, seven corners. Octagon eight sides, eight corners. Nonagon nine sides, nine corners, and decagon 10, 10. Now they're saying which sequence you do you get. If you will see this sequence, this is a sequence of counting numbers. And similarly, if you will see the next sequence, that's a sequence for number of corners. Again, it's a sequence of counting numbers. So question is, do you get the same sequence? So you will write yes. Yes, in both the cases, sequences same. Yes, both sequences are same. But they're asking, can you explain why this happens? So you have to explain that. You will write because in regular polygons, because it's a regular polygon. So we know in regular polygons, or you can write because in n-sided regular polygon, we have number of sides equal to number of corners equal to n. That means in case you have a any polygon that have, you can say n-sided, that have n sides, so obviously it have n vertices, n angles. That's why both are same. Now let's move to second question. Count the number of lines in each shape in the sequence of complete graphs. Which number sequence do you get? Can you explain why? As you know that we have already discussed, I will show you that again. See, this is complete graph. So here, you know that in first case, we have one line, then three lines, then six lines, then 10 lines, then 15 lines, and this is the sequence of triangular numbers. And even I told you that if you have, see here, for Kn, we have n into n minus 1 by 2 number of lines. So we have to write these two things here, that number of lines in each shape in the sequence of complete graph are 1, 3, 6, 10, 15, and so on. Now they're saying which number sequence do you get? So we have written that it's 1, 3, 6, 10, 15. But did you notice something here? Which sequence is this? Yes, you can also write this sequence is of triangular numbers. And you can just mention one more thing, that we know that number of lines. Here lines means including the both the things, sides as well as diagonals. So number of lines in Kn, where n is, you can say, where n is number of vertices that we have points. So number of lines in Kn, that's K is for complete graph, is n into n minus 1 by 2. So if you know this formula, you can find number of lines for a complete graph. Like if they will ask, can you tell me the number of lines for K11? You can simply say 11 into 10 by 2. You can cut that, that is 55. So if you know this formula, you can simply find number of lines in any complete graph. Let's move to question number 3. How many little squares are there in each shape of the sequence of stack square? Which number sequence does this give? Can you explain why? So I will show you again that stack square, this one. So here we know that in stack square, it's 1, then 4, then 9, 16, 25. So it's a square number series. And here the rule is number of small squares in each row and column of next shape is one more than that of previous shape. And total number of squares is always a square number, because here number of squares in each row and number of squares in each column is always same. So whenever you have to find the total number of squares, you will multiply them, and it's as it's same, so it will give you a perfect square. So that will write here in question number 3. So I'm writing answer for you. There are 1, 4, 9, 16, 25, and so on little squares respectively in each of the sequence of stack square. Yes, and why is it so? As I just told you, it is because number of little squares in each row and column are equal. And to get total number, we have to multiply them. And to get total number of squares, squares means little squares, we have to multiply number of little squares in each row and column. And when you multiply the same number, you always get square. And when we multiplied the number with itself, and when we multiplied the number with itself, we get a square number. Now let's move to fourth question. How many little triangles are there in each shape of the sequence of stacked triangles? Which number sequence does this give? Can you explain why? Hint, in each shape in the sequence, how many little triangles are there in each row? So as I've just explained this thing to you, so I will show that to you. See, stacked triangle, as I told you that how we can find the total number of triangles, we have to see row wise. Like in first row, we have one triangle, then second three, then five, then seven, and so on. So if we'll add the consecutive odd numbers, you know that it will always give you perfect square. So we'll write this answer. There are 1, 4, 9, 16, 25, and so on little triangles. Not writing triangles, I'm using the short form. Respectively in each of the sequence of stacked triangles. Yes. Now I will write this that in one square you will get 1. How you will get 2 square? You're getting like 1 plus 3. Then you get 3 square. If you want to write like 1, then 4 is this, 9 is 3 square, and that is 1 plus 3 plus 5. Then 16, that means 4 square, that was 1 plus 3 plus 5 plus 7. And then 25, that was 5 square. 25, that was 5 square, and that is sum of first 5 odd numbers that we observed there. So you can write here adding first n odd consecutive numbers, and that will give you always n square. Yes, here we use this thing, and you can write these are squares, because it's just you're writing now these are squares because it's representing the sequence of square numbers. Let's move to last question of this chapter. Question number 5. To get from one shape to the next shape in co-snowflake sequence, one replaces each line segment by a speed bump. That means you're replacing one line segment to four line segments. As one does this more and more times, the changes becomes tinier and tinier, very, very small line segments. How many total line segments are there in each shape of the core snowflake? That what is the corresponding number sequence? So I will show you that again, core snowflake. Just see this core snowflake. First we have 3 line segments, then we have 12 line segments because we are replacing every line segment by a speed bump, and that means we are replacing one line segment by 4 line segments. Then again into 448, and then again into 4192, and then again into 4768, and so on. So let me write that for you. Here it's not written that you have to draw the pictorial representation, so you will not draw anything. We'll just write this thing that there are 3, 12, 48, 192, 768 small line segments in each shape of the coach snowflake sequence. Here you can write one more thing, as I told you that we are replacing the line segment by speed bump, so that means into 4. That pattern, how we getting next number. So how we can write 3, 12, 48, 192, as they have given you hint also. You know that here we are multiplying with 4, but in first we are not multiplying with any number, so I can write 4 raised to the power 0. In next we are multiplying with 1, 4 raised to the power 1, then 4 raised to the power 2, then 4 raised to the power 3, and then 4 raised to the power 4. As you know, if you multiply this by 4, then when power of 4 is increases, here you also you are multiplying by 4, then you are multiplying by 4, and then you are also multiplying by 4. So you can write these answers that this is 3 times power of 4. That means number of line segment in co-snowflake sequence is 3 times powers of 4.
So that's all for today. And with this, we complete Chapter 1 Patterns in Mathematics. Stay tuned for the next chapter on Mathify with Meenakshi and keep learning with me. If you enjoyed this video, don't forget to like, share, and subscribe to my channel Mathify with Meenakshi. Thank you, everyone.